So here we are again with the decision tree topic, and we have this practical implementation of decision tree. So here I am on the platform called Kaggle. You can also use Google Colab for implementing the same. I'll be sharing the code. Uh, in this platform, it is almost similar to Google Colab, and it is have some added functionality that you can have GPUs and all, and also it has a good UI, and you can also add easily data here. So here, okay, so I'm just going to try to execute this and explain you the decision tree classifier. So let me run this. So basically, in the first line, what we are doing, we are importing some of the library, for example, NumPy and Pandas, and from Sklearn tree, we are importing decision tree classifier. So what these all things are? NumPy is used for array management, and Pandas is used for data frame handling. And Sklearn is a very famous library. You can go and try to look here at Sklearn. It's a library where you have all the pre-implemented machine learning algorithm you can find easily at this place, that classification, regression, random forest, and all. So you don't have to write everything from the scratch. Okay. So this is what we are doing in the first line. So we are importing some of the libraries which are required for the purpose. Next, we are loading the input data. Okay. So there is some issue with this. We don't. I think we don't have this input data. Let me do and check it. Okay, now it's fine. Uh, we have imported this drug dataset, which have the columns age, sex, BP, cholesterol, and there is one other so column which is sodium to potassium, and we have to predict which kind of drug this is. So there are certain classes like drug Y, drug C, drug X, and so on. So this is the basic data set. We have input field as age, sex, BP, cholesterol, sodium to potassium, and the output field as drug. So let us look what is the size of this. It has a size about roughly 1200 entries. So next, let's convert this columns into values. Okay. So these are the values which you can see for the first five inputs. Like we have 23 as input and female and high and BP, cholesterol, all of the things you can see that it is just to visualize some of the few entries from the top. Okay. Now, next we are doing some pre-processing uh, steps on them because you can see there is these fields are categorical in nature. Like these are strings, female, male, high, low, and sklearn cannot handle this kind of thing. Like because it needs some numeric data to run on operations. So there is some pre-processing using pandas dot get dummies you can use, or you can have a label encoder. What label encoder would basically do is like this will convert this female male to a certain number, for example 0 or 1 or so on, high or low to 0 1 or 1 or 2, and so on. So basically we need to just convert with one numeric data type. So this is the we are importing pre-processing from Sklearn. Again, Sklearn is a library you can check out and search. For example, pre-processing here. Pre-processing, and if you go and search, okay, I think you can go out and okay, here it is. You can check out and what all function pre-processing contains. Okay, you can see there are multiple number of pre-processing functions you have with you, and you can perform various other like feature extraction you can do, you can discriminant analysis, decomposition you can do, you can have dataset function, you can find covariance and so on. So this is the functionality of the pre-processing. So from there we are having label encoder, which will basically encode this female and male of all the columns into certain numerical values. And similarly we are doing the same thing for the low, normal, and high, which is the for the BP field. And again, for the sodium potassium field, we are doing the same thing. Okay. And now we'll just try to run this. And you can see now it has been converted to zero ones, as I have said. Like females had been turned to zero and males had been turned to one. And similarly for the low, high, and normal, low will be turned to zero and normal will be one and high for two. This is how the conversion had taken place. Now let's see the output column. As I have told you, this is a data set. These first features are the inputs and this drug column is the output. Right. So let us look what drug column looks like. So it has various things. Okay. Drug Y, drug C, drug X. So this kind of input it has. Okay, now next, what we have to do is a train test split. So what basically train test split is, if I want to simply explain that, for example, there are 2000 entries. So you need to train your model on, for example, 1500 entries and then try to test it on some remaining 500 entries. This is how all the machine learning algorithms work. So just we are importing that sklearn from model selection, train test split, and we are running train test split. Okay. So here we are giving X inputs, which are basically our first few columns of the input. Right. Here I have already told you. And Y is input, which is our drug column. We are defining a test size to be zero point 0.3, like 33% of the data will be test and remaining will be used for training purpose. And random state is another parameter you can play along and provide any value 0, 1, 2, 3, 40, 50, any. Okay, so this is basically test range split. So it will take a few moments. Okay, it has done. Now we will create an instance of a decision tree classifier called tree, and we'll provide some hyperparameters to it. What these hyperparameters are that we want our max depth to the before that we have already studied what max depth is. And another is what kind of splitting criterion you are going to use. So there are basically two types of methods to check better about this purity. One is entropy and another is Gini impurity. So here we are using entropy. So it has initialized our decision tree and it has some other parameters. You can see the min sample leaves is 1, min sample split is 2, min weight fraction is 0, and pre-sort deprecated. Okay, there are something and criteria we are using entropy. Now we are fitting our model. Now we will predict and look upon some of the predictions and inputs. So this is the predictions which have been done for input, and this is the actual thing. So okay, it's predicting wrong for this, right for this, right for this, right for this. So it is pretty good. Now there is next step. We are testing the accuracy of our model. Okay. So how to check accuracy? There is a inbuilt function in the sklearn, which is a matrix, and you can use the accuracy score. Accuracy score is basically the number of true positive plus true negative divided by true positive, true negative, false positive, and false negative. That you can understand in the theory thing. So that the accuracy is around 98%. Fair enough. Now let's plot out the this tree, that how it looks like. So it will take a few moments to do this. Okay, this is how this splitting is taking place. That I have already told you. Let's see like this. That will move to left or right, whether. So this is how it is done. So this is how decision tree classification takes place. So this is an example of decision tree classification. To understand a topic like decision tree regression, there are some articles you can. There are resources which I want to tell you that from where you can explain and experiment and play around different machine learning algorithm. One is you can go to directly to sklearn and search anything there like tree regressor. There is a spelling mistake. I haven't done this quite. Let me type it. Decision tree regressor. Not should give the output. There are certain things you can play around. Okay. Now there is another website which is called Medium. So you can go and search decision tree and you'll come across some of the article like this. which will obviously explain about the theory which I have already done. And there has another example of decision tree regression. So regressor is basically same as classification, just that it predicts the continuous outputs. So in with this website, you can uh, like understand that how decision tree regressor works. It contains almost the similar steps. Yeah, we have a data set, we have certain inputs. There is an example of like whether we should purchase a product or not. So there is an example of tree that okay, if the price is greater than 10K dollar, we'll decline this. If the price is less than 10K dollar, we'll look upon another features like whether there's a bad mileage or good mileage. Okay, what is the safety thing? If there's less safety, we'll obviously decline this, and so on. So this is an example of classification. And for regression, we can just consider another example that what is the price of the particular car based on the given classifications like whether it is diesel engine, petrol engine, what is the mileage and all. So this is the kind of thing you can perform with the help of regression. There is another website like which I have already told you. This is the Kaggle thing. So in the Kaggle, you can go and search for various decision tree related notebooks. The people upload notebooks, sorry, for the purpose of learning. I have used one, and you can simply upload the data out here. So this is basically the practical implementation of decision tree. In case you want to search for some other models, you can also go for the Sklearn and the classification. Uh, and even if you directly try to Google it, decision tree classifier, Sklearn, it will give you the first output as the Sklearn decision tree classifier. Here you can also get to know about various criteria which we have tried. Okay, here we have put that criteria as entropy. Right. You can also see that here there is another property called Gini impurity, and another is log loss. So there are various type of operations you can do, and various hyperparameters you can play around. There's minimum samples, minimum leaves, minimum weight, and this all thing you can play around and check which all model gives you the better accuracy. So I think that's it for the decision tree classification. Uh, Thank you. I think you have got the understanding of uh, what decision tree regression classification.